All right, there are a number of things in section 2.6 that we need to talk about. The first of which is domain of a function. And by definition, that's the largest set of real numbers for which f of x is a real number. Okay, well, what does that mean? That means the domain of our function is only going to include values of x that give us real number values for f of x. And the way that you can kind of streamline the way you think about this is to think about what we should exclude. And we want to make sure that we exclude from our domain any numbers that cause division by zero or square roots of negatives. So, to look at a couple of examples, suppose we have the function f of x equals x squared plus 3x minus 17. Okay, well, when I look at that function, I don't see a fraction. So there's no way that I can have division by zero in this case. I don't see a square root, so there's no way I can have a negative number under a square root. That would be a problem. And in fact, there's, no matter what real number I plug into f of x, I'm going to get a real number back. So the domain of this function would be all real numbers, negative infinity to positive infinity. Function g of x, on the other hand, is going to have a more restrictive domain. G of x is defined as 5x over x squared minus 49. And I, first of all, see a fraction here. So I know that x squared minus 49 should not ever be allowed to equal 0. Then I would have division by 0, and that's bad. Well, x squared minus 49, you can factor that as a difference of two squares, x plus 7, x minus 7. And then you can think that x plus 7 should never be allowed to be equal to 0. X minus 7 should never be allowed to be equal to 0. So from that, we can conclude that x should not be negative 7. X should not be positive 7. But any other value of x is okay. So if we're talking about all real numbers except negative 7 and positive 7, I'm going to show you this on a number line. It makes it a little bit easier to see. So we would have open circles at negative 7 and positive 7, and then the entire rest of the number line would be shaded. Any other real number except those two is fine. So given that as an interval, or in interval notation, it would be negative infinity to negative 7, union negative 7 to positive 7, union 7 to infinity. All right. For function h of x, if we're trying to find the domain, h of x is a square root of 9 minus 27. Okay, well, I know that to take a square root, I have to have a positive value. So here's what I'm thinking. 9x minus 27 has to stay greater than or equal to 0. Well, that means 9x is greater than or equal to 27. X is greater than or equal to 3, and that is the domain of this function. This domain would be 3 to infinity. As long as x comes from one of those values, then you're going to have a positive value under the square root and have a real number value for h of x. So the domain here, here, and of course the domain of all real numbers in our first example. So really what you kind of try to think about, the way I approach this is I think, what can't happen? And in function f of x here, there is none of the bad things, like dividing by 0, 0 in the denominator of a fraction, or square roots. None of that's there. So the domain is all real numbers. And function g, because I've got a fraction, I know that the denominator, what can't happen is the denominator equals 0. So I start by thinking the denominator cannot equal 0 and go from there. In function h, because of the square root, my thought process is that we have to take a square root of something that is not negative, so greater than or equal to 0, and solve that inequality. That tells you the domain.